Hooray, it's time for our third data structure as we continue down to our different data types in Python. And this one is called a tuple or tuple, depending on how you like to pronounce it. And we actually saw this slightly when we talked about dictionaries. But before we get into that, what are tuples? Well, a tuple are like lists, but unlike lists, we cannot modify them. They are immutable. So you can think of them as immutable lists, and they look like this. So let's call it my tuple is going to use brackets to denote a tuple. And we could do 1, 2, 3, 4, 5, just like a list. Now, you remember how in a list we could have modified this and said index of 1, well, now is going to equal z. If I run this, it's going to error out. It's going to tell me, hey, tuple object does not support item assignment. A tuple is immutable. Once you create it, it's the way it is. You can't sort it or reverse it like we saw with lists. It's just there. What about this? Can I just print a tuple and just grab the second item on that tuple? Well, yes, you can. Just like a list, you can access it through an index. Can I maybe does 5 exist in my tuple? Just like we could in a list? Well, yes, we can. The difference is that it's immutable, right? Now, why do we need this? I mean, we already have lists, so why do I have to learn tuple if? You know, it's pretty much the same as list. The only thing is I can't change it. There's a few benefits to this. For example, if you don't need to change the list, that makes things easier because it tells other programmers looking at your code, hey, this shouldn't be changed. Unlike a list, I want this to stay the way it is. Keep this order. So it makes things easier and more efficient. It makes your code safer because people can modify it, right? It makes code more predictable. However, it makes code more predictable, but it's less flexible than a list. I can't really sort a tuple. I can't run reverse on tuple. Now, because of this, because they are less flexible, the other good thing about them is that they're slightly more performant than list. So they're usually faster than list. And if you don't need a list to change, well, use a tuple. So a good use of a tuple, for example, if you work at Uber, is geographic location and coordinates, right? You can have latitude and longitude here. And because, let's say this won't change, or maybe a user's location or pickup point doesn't often change, we can just use a tuple. However, maybe when you're in a car as a driver and you're an Uber driver, well, you probably need your coordinates, your latitude, longitude in a list because your car is moving. That's constantly changing. And we saw tuple when we talked about dictionaries, right? Remember when we did user or we did user.items? And then I said, hey, just print user.items. And we saw here that we got a dictionary items. And inside of this dictionary, we see that basket 1, 2, 3, greet, hello, and H20 are a tuple. So this actually returns our key and value as a tuple. And as I mentioned before, a dictionary can have keys that are immutable. So a tuple is a completely valid key in Python. So I can do 1, 2 here, and that is a valid key in a dictionary. And the way I would access this would be like user, curly bracket, 1, 2. So that if I click run here, oh, I have an extra bracket. Let's fix that. Let's click run again. And there you go. I'm able to grab user tuple 1, 2 and grab 1, 2, 3 list. You see here how I'm trying to use different data structures, combining them together. Let's take a break and finish off our understanding of tuple in the next video. Now, tuples, like I said, are quite similar to lists. So if I wanted to, I can say new tuple and use my tuple and then slice that tuple. So for example, if I do 1, 2, like this, and print new tuple, I'm going to get 2, comma. Why is that? Well, we start at 0, 1, and end at 2. If I did 4 here and click run, I get 2, 3, 4. It's still a tuple, but you have to remember that a tuple that only has a single item tends to have this little comma at the end, but it's still a tuple. And just like a list, I can assign different things. For example, I can say x equals to my tuple 0, and then I can say y equals my tuple 1, and x and y will equal 1 and 2. But a short form of doing this, again, similar to lists, is to say, hey, I want x, y, z, and you know what? Other to be the values assigned from the tuple. So that if I do x here and I run, I get 1. If I do z and I run, I get 3. What if I do other, and if I click run, I get 4 and 5 as a list. Alright, if your head doesn't hurt by now, don't worry, I have some good news. Luckily for us, a tuple has only 2 methods that we care about. Count and index. How nice is that? So nice and simple. Guess what these mean? So let's go back to my tuple. And now try these out. If I go my tuple that count, well, it's going to count the value. So if we want to count how many 5s occur in the tuple, I get 1. If I had another 5 in the tuple, I get 2. What about index? What's the index of 5? Well, the index of 5 is 4. Because 0, 1, 2, 3, 4, the first value that it finds, it's going to return the index of. And then finally, we can also do length, right? We can use this built-in function to run length, and it's going to tell us that, yep, it has a length of 6. Awesome. There it is. We're flying through them now. This is our third data structure. Remember, they're simply lists that are immutable. I'll see you in the next one. Bye-bye.